All right, so we'll pick up where we left off. Before we get started, a couple things. So we've got participation quiz from today. We'll kind of go through later in the class. After the class is over, I will post the Module 9 quiz. Quick turnaround on that. That's due by the end of the day tomorrow, right? So we've got that Module 8 quiz, participation quizzes for Module 8, these participation quizzes for Module 9, and then the Module 9 quiz, all due by the end of the day tomorrow, because on Friday, we'll have that second midterm exam, right? So I'll kind of add that second exam here. So it'll be there. You can't access it until Friday. Friday, once again, kind of similar to the first exam, it'll be open from 11:15 to 3:15. You'll have an hour and 15 minutes to get on, get it done. Start at any time that you want within that time frame. That means that you have to start at the very latest 2 if you want the whole hour and 15 minutes. It'll be kind of a similar to the first exam, probably a little bit more kind of formula-based questions or kind of fill in the blanks, as opposed to there will also be most of it is going to be multiple choice. Excuse me. But we'll kind of look at those practice problems. I'll kind of even tomorrow we'll go through a lot of them. I'll kind of say how I could convert some of those multiple choice into like a formula-based question, or a fill in the blank question. But we will go through more of that practice exam or practice problems tomorrow. So we will finish Module 9 today. Other than that, I put an announcement up yesterday. My office hours today and tomorrow, instead of being in the morning, are going to be in between the two classes, so 12:30 to 2. If you do want to kind of meet any last minute questions tomorrow, I'll be available during that time slot as well. Otherwise, there's no questions for me. We'll kind of just jump into trying to get through Module 9 here. We might get through it a little bit quicker here today. Okay. All right. So last class, we were talking about, the firm's decision is to maximize what we said was economic profits. We want to factor in both explicit and implicit costs. When we hire more workers, we're generating output, which we can then sell for whatever the price of that good is. So that's kind of like the benefit of increasing our output. However, when we want to increase our output, we said in the short run, things were fixed, like the building we were in or our machinery, but we can always change the number of workers we have. So as we hire more workers, we can get more output. That's going to be able to sell that for a certain price. That's the benefit, but the cost is whatever the cost of the worker was. So we're really going to focus on the cost of the firm as opposed to the marginal product here today. We kind of made that relationship between the marginal product of labor and marginal cost last class. So now we're really going to focus on the firm's costs. So we're going to have 3 different types of costs we look at: fixed, variable, and total. So fixed costs, this is just things that we can't change in the short run. So this is going to be like if we're locked into a lease agreement on a building, the rent that we have to pay. I think in the example that we used yesterday, I had that was like $1,000 a month for Chipotle. But this could be the cost of equipment, loans that we've taken out to pay for that equipment, rent on a building. The thing that we're really going to think about just for now as going to be our variable cost is going to be labor, right? We can hire and fire more workers, and so our variable costs, the things that we can change in the short run, are primarily, for the sake of our examples, just going to be the cost of labor. Now, you could have cost of raw materials. Maybe I switch over I find a different supplier. If I'm, making my Chipotle, maybe I find a new supplier of corn or something like that. But for us, we're going to focus just on kind of labor. Total cost, just the sum of those two things. Okay, so nothing crazy here. So if we think about these different cost curves, right, what are they going to look like? Okay. Well, my fixed cost is kind of an easy one, right? Fixed costs are going to be costs I have to pay no matter what my production decision is, right? So if I decide to produce nothing or 100 units or 1,000, I still have to pay for that rent, the agreement that I made, that lease that I signed. And so my fixed costs are always going to be the same no matter how much I produce. Right? It's the things that I cannot change in the short run, and so I'm locked into these costs. So if you think about our fixed costs, it's just going to be this horizontal line. Okay. Excuse me. Our variable costs are going to be what, as we produce more, we're going to see that those are increasing, right? If I want to produce 1 unit, I hire, a worker. 2 units, I have to hire the next worker, et cetera, right? So, excuse me. What we said last class is we've got this variable cost curve. Now, we'll kind of ignore this area here, but remember, eventually, as we are hiring more workers, we said initially there might be some gains from specialization. So the change in our cost could actually be going, in our marginal cost, they could actually be going down. But eventually that diminishing returns takes over. And if we want to increase our output by one more unit, it's going to become more and more costly. Or the slope of our variable cost curve, that should represent, well, it's the change in our cost divided by a change in output. That should represent our marginal costs. Okay. Now, the slope of that total cost curve should be pretty similar, right? That change in our total cost should always be the change in variable cost. Right? Now, it's going to be a little bit higher because it not only includes the variable cost, but it also includes this $100 fixed cost. So the difference in between these two lines, it's not quite drawn to scale, but it should always be that $100. Okay. So I've got my fixed cost, always the same no matter how much I produce. My variable and total costs, because total, is the sum of variable and fixed, those are going to be increasing as we produce more. Okay. So if we look at that total cost, we said marginal cost will be the change in total cost divided by our change in quantity. So here, if we go from 0 to 1 units, that change in total cost, right, is 70 divided by the change in quantity of 1, so just 70. So this is an easy example because the changes in quantity are 1. We'll look at some harder examples here in a second. Now, initially, right, we said my marginal cost, if they're 70, if I want to produce the second unit, maybe I'm getting still gains from specialization by hiring more workers. So notice for that second unit, the change in my total cost is only 50. So initially, my marginal cost might be going down. So in this range, right, from 1 to it looks like 3, my marginal costs are decreasing. We know that for those quantities, it must be that we're still experiencing gains from specialization from hiring our workers. Now, eventually, over time, those gains from specialization go away. I'm just hiring less and less efficient workers. So what starts to happen to my marginal costs? They start to go up. As I want to produce more, I'm relying on less and less efficient workers. So my marginal costs are going to be increasing. So from that quantity of 3, from 3 onward, we're going to have diminishing returns to labor taking over, or we're going to have our increasing marginal costs. Okay. So, we might have some examples, not really in this module, but after the second exam, some of the modules that we'll look at before the final, we might simplify some of our models to have constant marginal cost. But really, in reality, if we're thinking about our labor, right, is going to become less and less efficient, we know that we're going to have this increasing marginal cost. Okay. So if we're going to put that on a graph, we said, okay, this initial portion where marginal costs are going down, that meant that our marginal product of labor was going up. And then as soon as marginal costs start to increase, that must mean our workers are becoming less and less efficient. We are now on the diminishing returns portion of that marginal product of labor curve. So our kind of marginal cost always, I always say, kind of looks like this like a little Nike swoosh symbol. I think I've got a graphic on one slide here. So we're then going to start thinking about average cost as well. So for the average fixed cost, right, if I think about I'm taking the same value, right, my fixed costs are the same no matter how much I produce. So as I produce more, essentially, I'm spreading these costs out over more units. Or if I'm calculating an average, what is an average? It's just take that total. So the average fixed cost would be my total fixed cost divided by quantity. So notice initially, my average fixed cost, if I only produce 1 unit, that cost is only being spread over 1 unit. I've got an average fixed cost of 100. Now, once I produce 2 units, I've still got that same total fixed cost. I'm just spreading it over 2 units now. So the average cost per unit, or the average fixed cost per unit, would be 100 over 2 or 50. And then 3, it's 100 over 3, 33, et cetera, et cetera. So what's always going to be happening to my average fixed costs? Well, my total fixed cost always stays the same. So as I produce more, if I'm dividing by a larger value, my average fixed cost should always be decreasing. Okay? And you kind of think about this shorthand here, right? If I'm thinking about my average fixed cost is my total fixed cost over quantity, well, this stays the same. As I produce more, my denominator is larger. This whole fraction must be going down. Right? So when we're graphing out over different quantities, our average fixed costs are getting closer and closer to zero. Okay. That's kind of where that comes from. Okay. Now, if I think about my average variable costs, right, what are those going to be? Well, all I'm doing there is taking my total variable cost and dividing it by quantity. So here it's not as easy, right? Because it's not a constant value for variable costs. My variable costs are changing as I produce more and more, right? I'm hiring more workers. The workers have different marginal products of labor, so my marginal costs are varying. So for our average variable cost, all we're doing is taking that variable cost, dividing it by quantity. So here it'd be what? 70 over 1 is 70, 120 over 2 is 60, 160 over 3 is 53.33 repeated, right? So our average variable costs, we'll kind of see that initially they start to decrease, but then eventually, because my workers are becoming more and more inefficient, they eventually start to increase because of those increasing marginal costs. Okay. So our average variable costs is going to kind of have this U shape to it. Okay. And then we could do the same exact thing for average total. There really shouldn't be anything crazy. I'm just taking my total cost, dividing it by quantity. So average total cost is going to have a similar shape to average variable costs because initially it's going down and then eventually it starts to increase. And I'll come back to this in a second. I just want to show you the visual. So here would be kind of our average total cost curve. Okay. So one thing I wanted to point out was if we looked at the average total cost, it should just be the sum of our average variable and our average fixed. So if I take those numbers that we already had for average variable and average fixed, notice if I add average variable to average fixed, I get my average total cost. So why is that the case? Well, if total costs are equal to my variable cost plus my fixed costs, if I divide both sides by the same thing, that doesn't change the equality. Well, what is total cost over quantity? Average total. What is variable cost over quantity? Average variable. What is fixed cost over quantity? That's average fixed. So I can find my total cost by adding up variable and fixed costs. This same thing will apply if I want to find my average total cost. That would be my average variable plus my average fixed. Okay. So with this idea in mind, if I'm thinking about, in our example, we said average fixed cost is doing what? Always decreasing, right? So if I'm then thinking about, if I've got my average variable costs here, we said it kind of has this U shape to it. What's going to be true about the difference between my average variable and my average total? Well, the difference will always simply be my average fixed. So if my average fixed is getting lower and lower, sorry about that, what's happening to the gap in between my average variable and initially my average total? Well, initially it's relatively large, right? And then as I'm looking at higher and higher values, well, now that gap is getting smaller. Eventually, when I get down to out here, well, now the difference between average total and average variable is going to be very small. So my average total will always be above that average variable cost. But as I produce a higher and higher quantity, the difference in between those is getting smaller and smaller. Okay. Any questions on that? Okay. All right. Give me 1 second here. We'll switch back. Okay. So we've got, oh, if I can get this off the screen. There we go. So we've got our average fixed cost is always decreasing. The average variable, average total kind of have this U shape to them. And then we always know the average total will be greater than the average variable, but that gap is going down or getting smaller and smaller as we produce a higher and higher number of units. Okay. Any questions before I then add in marginal costs here? Okay. All right. So let me think how I want to do this. We have this table. I want to spend some time on this table, but I think I'm going to jump the gun a little bit here and allude to something. We'll talk about this again later on, but I think it's worth bringing up at this point. So what'll end up being true is just like our average product of labor and our marginal product of labor, we said that whenever the marginal cost was below, or sorry, the marginal product of labor was below our new average had to be lower. And anytime the marginal product of labor was above our new average is going to be higher. So same kind of thing is going to apply to costs. Because marginal cost is how much I'm adding to the cost, if it's below my averages, my new averages are going to be lower. So what ends up being true is this marginal cost. Initially, we have this gains from specialization where it's decreasing, but eventually it starts to increase because diminishing returns to labor takes over. And what's going to be true is it hits my averages at their minimum point. And it's the same logic as we have for the marginal product of labor. Anytime, and I'll just use average total for the sake of this example, if my marginal cost is below my previous average, I'm adding a value. So this is the idea. If I currently have a 15 on the quizzes and I get a 10, well, that additional quiz score or the additional cost is lower than my previous average. My new average is going to be lower. Anytime I have a quiz score, if I got an average of 15, if I get an 18, well, now when that additional quiz score or my additional cost is above the old average, so I can kind of do this range over here. I'll do this in red. If the additional cost is above the old average, my new average must be higher, or my average total cost is increasing. Okay. So the same relationship is going to exist for marginal and average costs as it did for marginal and average product of labor. Any questions there before we keep moving? Okay. So, here's going to be all of our cost equations. I'll put together a formula sheet and actually get that posted this afternoon. You should be able to, pull this, you should print this slide out or kind of copy this slide down to make sure you're having it. But I'll get a formula sheet in Word that you can kind of have all these formulas in one place as well. But, really, it's nothing crazy. To find an average, we just take whatever type of cost that is, divide it by quantity. So that's average total, average fixed, average variable. Our total costs are just the sum of our variable and fixed costs. So the same thing we said holds for the averages. And then our marginal cost, how do we find the marginal anything? It's the change. So if marginal cost, it's the change in that total cost divided by, well, why are my costs changing? Because I'm changing my output levels. Okay. So got these kind of boxed off. Let's try to think about if I had, and usually I would say take some time with classmates to try to fill this out. You're not next to classmates here. So I will kind of work along with you for this. So I am going to stop this and I'm going to write this out for us here. Okay. So we've got quantity, we've got 0, 1, 2, 3, 4. We got our total variable costs, which are, we only have this one, which is 7. We have total fixed costs. We have total costs. We have average variable. Let's see if I save myself enough room. Average fixed, average total, marginal costs. Okay. And then I had here 720. I had here 740. And then just make this a little bit easier on myself. So average variable here was 15. We had 202 down here. So it doesn't look like we have a lot of information, right? But we can actually, just from the information given here, fill out this cost table, right? So the very first thing I would always do is try to figure out fixed costs, right? fixed costs are always going to be the same. So once we know it for one quantity, we're going to know it for all the other. And then once we know that, we can find average fixed costs. So typically I would go to that quantity of 0 and think about, okay, if my total costs are 720, if I'm producing nothing, what are my variable costs? Well, if I'm producing nothing, how many workers do I have to hire? 0. So at 0, my variable costs are 0. So if I have total cost of 720, what must all of my costs be when I'm producing nothing? Fixed costs. So once I know the fixed cost at one quantity, I know the total fixed cost at every quantity, right? This was the idea when I was paying like $1,000 for rent. It's the same no matter how many burritos I produce. Okay. What if I wanted to find the average fixed cost? Well, we said that was simply, if I want an average, take the total, divide it by quantity. So 720 over 1 is 720. Oh, sorry. I'm in the wrong one. That would be 0, right? We're not producing anything. Here, in that quantity of 1, it would be 720. At a quantity of 2, 720 divided by 2 is 360. 720 divided by 3, it's going to be what? 240, if I'm doing math in my head correct. And then 720 divided by 4, that's going to be what? 180, if I'm doing math in my head correct there. I'm actually going to cheat. Okay, just making sure. All right. So I've now got my average and my total fixed cost all filled in. Okay. So what are some other things I can now fill in? Well, anytime I know the variable and fixed cost, I automatically am going to know my total cost, right? So I'll kind of start doing these in this is kind of one step. Here will be like the second one. So 727, right, must be my total cost there. I don't have my variable costs here, but I do have averages. So what is my average variable plus my average fixed? That's just my average total. So I can find my average total by summing up average variable and average fixed. Well, here's where, okay, if I know the average total is average variable plus average fixed, if I've got my average fixed cost, I've got my total cost. Well, now it's just a little bit of algebra to solve for that thing that I don't know. Subtract 180 from both sides, and I get what? My average variable cost here would be 22. Okay. Any questions? And I'm going through this a little quick here, but okay. Now, how can I find my average total costs? Well, if I know the total, my average total is just take that and divide it by quantity. Well, for this first one, anything divided by 0, we don't really have an average here. So these kind of don't really make sense for us. We can't have averages when we produce nothing. But at the first unit, my average total cost would be what? 727 divided by 1, so 727. At the second unit, 740 divided by 2, that would be what? 350 plus 20, so 370. I'm doing math in my head correct there. Okay. And then if I wanted to find my average variable cost, well, if I know my total variable cost, how would I find the average? That's just take total variable, divide it by quantity, so that would be 7 here. And then similar kind of idea. If I know the average total, I know the average fixed. Well, my average variable plus my average fixed is my average total. So what must my average variable cost be here? Well, the difference in between average fixed and average total is 10. So 10. Okay. All right, so we're getting somewhere now. Right. So how can I back out my total costs if I know the averages? Well, my average total cost is simply the total cost over quantity. So if I know that my average total cost is what? 255, that must be equal to my total cost divided by that quantity of 3, right? So I have what? Multiply both sides by 3 here, and I get my total cost must be what? 750 plus 15, so 765. And then I would do the exact same thing at the quantity of 4. right? It's just that now my average total cost is 202. I don't know my total cost, and I'm at a quantity of 4, multiply both sides by 4, and I get that my total cost here must be 808. Okay. Now from here, if I've got total costs, I've got total fixed, how can I find my total variable? Well, total costs are just the sum of my total fixed plus my total variable. So the difference between these must be my total variable cost. So here it would be 20. Here it would be 45. Here this would be what? 88. Okay. Any questions over how I filled in anything there? So we now have everything except for marginal costs. Okay. So I'm going to move this over a little bit. Make sure we can see this. Okay. So at these quantities of 0, I can't have negative production. So like our averages and our marginal costs, we don't really have a value there. Okay. What if, and I'll do this in red. Oh, I'll do this in red as well, just to kind of have a thing over here. What is my marginal cost, right? Marginal cost is the change in total cost over a change in quantity. Well, I know all of my total costs. I know my quantities. So notice, if I take the change in total cost going from a quantity of 0 to 1, the change in my total cost divided by change in quantity, this would give me what? Marginal cost of 7. Okay. And then what about for the second unit? Well, there the change in my total cost, 740 minus 727, divided by a change in quantity, 2 minus 1, I'd have what? 13. And then I could kind of keep going here. So I do what? 25 was the change in cost there. And it's kind of easy here because my change in quantity are 1. And then changing the total cost here is what? 35 plus 8. So 43, if I'm doing math in my head correct. So what's happening to our marginal costs? Here we must have no gains from specialization because my marginal costs here are always increasing, right? For every increase in output, my marginal costs are getting higher, they're increasing. Excuse me. All right. So I wanted to point something else out here that for the sake of time, or if you had a slightly different example, I can calculate marginal cost as the change in the total cost divided by the change in quantity. Let's say I didn't have these total cost columns, right? I didn't have either one of these, and I somehow didn't have this. How could I use my variable? Well, what part of total cost is changing? It's not being driven by fixed costs. Those are always the same. So I can actually look for the change in my variable cost, and that should be the same change I saw, there it is, in my total cost. Sure enough, change in total variable cost was 7. Change in total variable cost was 13, 25, 43. So technically, you can actually calculate your marginal cost using those variable costs as well, because that's the only thing in the short run that will change your total cost. Your fixed costs are always the same value. So if I looked at my fixed cost, what's the change in my fixed cost from every quantity? Just 0. Okay. Any questions before we keep moving here? Okay. All right. So, we've got that table. We just filled in all the values. I kind of walked through how we would do that. I kind of already alluded to this idea earlier, but if we're thinking about our average total cost curve, initially, because we have average fixed costs and they're being spread out over more units, well, my average fixed, if average total is just the sum of average variable, average fixed, my average fixed costs are falling down quite rapidly initially, right? I'm spreading that same $720 that we had in our earlier example over more units. Okay? So initially, I'm going to have that my average total cost is decreasing. Eventually, that average fixed cost gets closer and closer to zero. It's not changing by very much. Our average variable cost, we know if we produce more, we have to hire less and less efficient workers. Our average variable costs are going to start going up. And so eventually, we're going to see that the average variable cost is influencing the average total cost curve more, and we start to see that our average total costs start to increase. Okay. So the efficient scale of production is what we're going to call this minimum point of our average total cost curve. Okay. So the lowest possible point on the average total cost curve, we will call the efficient scale. That's where if we operate producing 5 units, we have lowered our average total cost, or you can think about this, we've lowered our per unit cost to the lowest possible value. Okay. So I already kind of jumped the gun a little bit. We also discussed that if I think about my marginal costs relative to the average, anytime I'm adding costs, anytime the change in my total cost is below the old average, my new average is going to be lower, right? So anytime that marginal cost is below our average total, it's the same relationship that we had with marginal product and average product of labor. Marginal cost below the average total, my new average total is going to be going down. Now, past this efficient point, right? If I keep going, there we go. When my marginal cost starts to be above the average, above my old average total, my new average total cost is going to be a little bit higher. Right? This is the idea. If I do better on the quiz than my previous average, it's going to pull up my quiz grade, my average quiz grade, sorry. So we've got kind of this point where marginal cost hits the average total, should be at its minimum. Because we know that we have increasing marginal costs after those gains from specialization are gone, eventually those marginal costs will be above the average total. As soon as they are, our new average total cost starts to increase. Okay. So we can see this from a numerical example as well. So I just kind of have some quantities here. They're not jumps of 1, so it makes it a little bit more tricky. But let's say I have my variable costs. I've got my average total costs. Right? So a couple of things we can kind of point out here. And I said that my average total cost here is 10. I can't really have an average. So what I was actually, in fact, what I really wanted to say here is, technically I don't have an average here, but the reason why I was putting 10, I almost wanted there to be like a, and I would make this more specific. So what do I want? I want like a little text box here. Let's assume that when I was producing nothing, I still had, where's the, why can I not find, there it is. That's size. All right, this might be more. Let's say I have the fixed costs are 10, right? So my average total cost should be the total cost, fixed cost plus variable, divided by quantity, right? So my fixed costs are 10. At every single quantity, I'm simply taking the variable cost, adding my fixed cost of 10. So total cost would be 15, 20, 25, 30, etc. To get the average, I just take that total cost, divide it by the quantity, not the change in quantity, but the actual quantity, because the average is telling me what are my total costs per unit spread out over every unit I'm producing. So initially, notice our average total costs are decreasing, and then eventually they start to increase. This was our kind of U shape, right? Initially they're decreasing, eventually they start to increase. Okay. Oh, went back a little bit too far there. My marginal cost will be the change in my total cost. Now here I said we don't have to have total cost. We know that the change in our total cost is always being driven by our variable costs. So I have the change in variable cost here always being 5. However, what's the change in quantity? That's varying. So for the first 20 units, my marginal cost would be the change in my total cost, or the change in my variable cost of 5, divided by that change in quantity of 20, 0.25. Change in my variable cost, 5, divided by now the change in quantity of 15, 0.33. So we can kind of think about here, if I was paying every worker $5, well, then when I hired that first worker, my variable cost went up by 5. They added 20 units. When I hired the second worker, they added 15. Third worker, they only added 10. So when my marginal product of labor is decreasing, what should be happening to our marginal costs? Well, if I have less and less efficient workers, we said our marginal cost should be increasing, right? Sure enough, as we produce higher and higher quantities here, our marginal costs are increasing. Now, what we can also see from this example is that anytime my marginal cost is above the old average, right? So below the old average, 0.33 is below 0.75. What's true about my new average? It's a little bit lower. And then when my new marginal cost is below the old average, my new average is a little bit lower. Right? So whenever marginal cost is below the average total, my average total costs are decreasing. That's going to be true for these quantities from 0 to 45. Now, if I want to produce past that quantity of 45, well, now my marginal cost is above the old average, so my new average should be a little bit higher. And then marginal cost, if I want to continue to produce more, marginal cost is above the old average, my new average is going to be higher. Whenever marginal cost is above the average total, my average total costs are increasing. And then we don't have an exact point here, but if we did have a quantity where marginal cost is equal to the average total, that would be kind of like no change in the average total. And that really only happens at one point. That happens at the very minimum point of our average total cost curve, where marginal cost intersects that average total cost. Okay. So a summary, right? Kind of just visual. It's also going to be true that same relationship between average total and marginal cost. The same thing applies to the average variable. Anytime marginal cost is below average variable, our average variable is decreasing. Anytime marginal cost is above average variable, our average variable will be increasing. And so it's the same logic that applied to the total cost, right? So we're going to have that the marginal cost hits the average total and the average variable at their minimum points. But we know that that minimum point will be at a slightly higher quantity for the average total cost than it would be for the average variable cost. Okay? And that's because average total also includes our average fixed. Okay? What do I want to say here? We'll kind of hold off on this. So any questions here before we keep moving? Okay. So I'm going to get us some more practice. And sometimes, this is really the goal. It's almost like practice problems with these participation quizzes. So we're waiting. There we go. So let's say I had this table. Let me make sure. I think it's the same for all of them. Yeah, I want to make sure I didn't pull away anything. So I'm going to write this down as I'm talking so that I can switch to kind of show you on the dot cam. So let's say I wanted to know the total variable cost of the 20th unit. So here we're given quantities, and now it's not quite as nice as the other example because I have jumps in my quantity not of 1, but of 10. So let me get this here. Oh, there we go. So I have my average variable cost. We had what? 35, 25. So I'm just filling this in from the quiz so that I can kind of show you the additional work, and I can reference this without having to keep switching back and forth. Right? So 5, 50 down here was 2, and then I've got my marginal costs, right? And then we had what? 25, 15, 20, 40, 50. Okay. So the first question asked us for what the total variable costs were at the 20th unit. Okay. Well, if I know my average variable cost at a certain quantity, I can always back out what the total was, right? So for that first question, I know that my average variable costs are going to be my total variable cost divided by quantity. So at a quantity of 20, my average variable costs were told to me to be what? 25. Okay. So a little bit of math here, multiply both sides by 20. That cancels. And I've got what? My total variable cost must be 5,000? Or no, 500, right? So this shouldn't be too crazy. Now, what if I had asked you the same question, but I asked you for the average total cost of the 20th unit? Well, I don't know or sorry, what if I asked you, sorry, for the total cost of the 20th unit? Well, I don't know my average total cost, but how could I figure out what that average total cost was at my 20th unit? Well, that's simply the sum of average variable and average fixed. I do know those things. So 25 plus 5. So I'd have an average total cost of 30. Now it's the same type of idea. I know my average total cost is the total cost over quantity. We just said my average total here is 30. The quantity we were looking at was 20. A little bit of algebra, multiply both sides by 20, and I get what? My total cost here must be 600. Okay. Now, hopefully, if I've done this correctly, I almost think about, I just found that my total cost here was 600. My total variable cost was 500. So what should my fixed cost be? The difference between those two? Well, notice if I know the average fixed, one way I could check to make sure I did all this math correct is my average fixed cost is the fixed cost over quantity. So if I know my average fixed cost is 5, a little bit of algebra here, multiply both sides by 20. Sure enough, my fixed costs would be that $100. Okay. So anytime I know an average and the quantity, I can always back out the total, whether that's total variable costs, total fixed costs. What did I say? Total cost, total variable cost, or total fixed cost, right? So the total variable cost we said was 500. Okay. What's the total fixed cost at 60 units, right? Well, I might look at this, and let's say I didn't even give you the average total or the average variable cost at 60 units. Let's just run with that example. So what you might do is say, well, look, I know I can find the average fixed cost by adding up average total and average variable. I now know the average, I know the quantity, I can back out fixed costs. But to kind of give you a harder example, let's say I asked you to find that total fixed cost at 60 units, but I didn't give you those averages. How could I find my total fixed costs? Well, if I can find my total fixed costs at any quantity, they're always the same. So the total fixed cost at 20 units will be the same as 60. So I'll use this one to make that point. If my quantity is 20, what was my average fixed cost? 5. So if I've got, and try to keep this on the screen here and do a little bit of work on the side. So my average fixed costs are just my fixed costs over quantity. We just said if my average fixed costs at a quantity of 20 were 5, a little bit of algebra here, I've got my fixed costs are equal to what? 100? Sure enough, that's what we found before. The fixed costs at every single quantity are going to be exactly the same. So the fixed cost of that 60th unit would also be 100. Okay. So that one's, I think, finding fixed costs generally are some of the easier kind of types of questions or easier questions here. What if instead, so I've got this third one, this one's probably quite a bit more difficult. So I left out the marginal cost for one of these, right? So I left out the marginal cost for the 40th unit. So if I wanted to find the marginal cost of this 40th unit, right? How could I do that? Well, what do I need? I need the change in my total cost divided by a change in quantity. Well, I know the change in quantity is 10. I don't have total costs, but I do have the average total cost, right? So I can find the average total cost, and I use the quantity. I can back out what my total costs were at a quantity of 40. Now, To get to that 40th unit, I had to go from 30 to 40. So how can I find my average total cost here? Well, I could do it a couple different ways, right? I know my average variable. I could back out what my variable costs were, and then I know that the total fix we said was 100. Figure out what my total costs are, kind of that way, right? So that's what we'll first do. So let's try to figure out what our total costs are at 30 units. Well, if I know my average variable cost is 23.33 repeated, right? So what I'm going to do is say, okay, look, I know my average variable costs are my total variable costs over quantity. So at a quantity of 30, the average is 23.33. A little bit of algebra. All right, should give me this guy here. So this is going to be what? My total variable cost should be 700, if I'm doing math in my head correct there. Okay, so my total variable costs were 700. Right? I knew that my fixed costs were 100, so my total costs would be 800 at that 30th unit. Now, what do I next need? Well, I need to change to find my marginal cost. I need the change in my total cost divided by the change in quantity. So I also need to find my total cost at the 40th unit. Well, there I've got my average total cost. So my average total cost is just the total cost divided by quantity. So at the 40th unit, my average total was 27.5. So this is going to be what? If I do the math here, I believe it's 1,000. Oh, wait, what did I? Sorry, this is a 7. 27.5. So if I do my math here, I think I get 1,100. So I now have the total cost of my 40th unit. I have the total cost of my 30th unit. My marginal cost is the change in total cost over the change in quantity. So I'd have what? 1,100 minus 800 divided by 40 minus 30, or 300 over 10. I should have a marginal cost here of 30. Okay. So that one took a little bit more work, but if I ever want to find my marginal costs, I'll need to have the total costs of both of these. Okay. Now, what could I have also done? I could have found my total variable costs here. So just to kind of make that point, if I wanted to find my total variable costs at 30 and 40 units, right? Well, if I know the average, right, we said that my average variable cost would just be taking that total divided by quantity 30. So if this is 23.33 repeated, we had before, oh, I did it over here. We already did that. We had, oh, yeah, okay, my total variable cost of the 30th unit was 700. Same kind of idea. If I want to find the total variable cost of the 40th unit, quantity is 40. My average variable cost was 25. A little bit of algebra shows me the total variable cost of that 40th unit was 1,000. So now if I want to calculate my marginal cost, if instead of using my total cost, I use the change in my total variable, I should end up with the exact same value. Sure enough, 1,000 minus 700 divided by 40 minus 30, I get that same marginal cost of 30 there. Okay. So in these types of problems, there's always usually more than one way to do it. And that's because we can use both total and variable costs to calculate our marginal costs. Okay. Any questions over anything there before we kind of switch gears a little bit? Okay. All right. So just to be complete there, we just said what? This should be 30. So, oh, did I select an answer for every question there? So we had 500, 100, and then that marginal cost of 30. Okay. So we left off thinking about the short run, right? Where we had a difference between our average total and our average variable. Okay. In the long run, everything is variable. Right? So in the long run, which of our curves is going to go away? Well, if everything's variable, what is our fixed cost going to be? 0, right? So in the long run, we don't worry at all about fixed costs because we can change everything. We don't have any. So our average total cost in the long run is the exact same thing as our average variable cost. Okay. So in the long run, average total is equal to average variable. So marginal cost hits both of those at their minimum point, but now they're the same thing. So it's going to be at the same point, right? This would be what we were calling kind of our efficient point of production. Okay. Now, this average total cost curve that we have in the long run, in the short run, we're really going to be facing several different average total cost curves. Okay. So I'll show you this in the slides, but I think I can do it justice here as well. So let's say I'm in my small production facility. I'm in a medium production facility. And here's my average total cost being in a large production facility. Okay. Notice for every quantity, say this QS, every quantity in this range, where are my lowest possible average total costs? Well, if I'm in my medium or large size plant, if I'm not producing very many units, I probably am spending money on a plant where I've just got extra space. I've got huge fixed costs, but I'm not producing that many units, so it's not getting spread out over more units. Which plant would I want to be in? Well, where are my marginal costs? Sorry, my marginal costs. Where are my average total costs the lowest? In that small production facility. Okay. Now, as soon as I get and I want to produce more than this quantity, for every quantity in this range, well, what size factory have the lowest per unit cost or lowest average total cost? Well, at this quantity, the average total in the small and large production facility, much larger than the medium. So for every quantity in this range, we're going to want to produce in that medium-sized production facility. And then any point past this, where are my lowest average total costs? Well, they're higher in the medium and small production facility. For every quantity past here, it makes sense in terms of lowering my per unit cost to be switching over to that large production facility. So in general, we've got not just like 3 different size facilities we can choose from. We really would have like a, if we do it by square footage, almost an infinite number of different building sizes we could choose. And so if we think about it more continuous, it's really going to be like all these different short run average total cost curves. We say like the minimum point of all of those, right? Kind of like we had here just with 3. This red kind of line where we're looking at the lowest possible average total cost of every size factory or every different value of this thing that's fixed in the short run that we can change in the long run, we're going to have this be the long run average total cost curve. We know that past this quantity, we'll never have the average total cost of being in a small facility because we would switch over to this medium-sized facility. Okay. So the minimum point of our short run, or the lowest possible average total cost of our short run average total cost curves, and I kind of already walked us through this, this is going to represent my long run average total cost curve. That maybe I am kind of locked into this short, small production facility initially, but in the long run, if I want to produce more, I can switch over to the medium-sized production facility. Now, the same thing is going to be true. In the long run, what do we want to do? Well, the efficient point is going to be at that minimum per unit cost, or the minimum point of our average total cost curve. So we're looking for which size production facility here would be the efficient scale. Well, which of them has the lowest possible average total cost? In this example, that would be the medium-sized facility. Okay, so I walked through this, with what I drew for you, but any quantity below this, the lowest per unit cost we can have is being in the small production facility. Any quantity in this range, the lowest possible costs, right, are being in that medium. And then any quantity past this, the lowest possible average total cost being in the large. Okay. And then Here would be kind of like a more continuous. I can choose a bunch of different factory sizes. It's going to be the long run average total cost curve is the minimum of all those. Okay. So when we have this long run average total cost curve, as we produce more, if our long run average total cost curve is decreasing, we're going to call that economies of scale. As we produce higher and higher amounts of this good, our per unit costs or average total cost are decreasing. The portion in the middle, and generally this isn't going to be as large as I have it drawn here. It's usually going to be like, really just one kind of quantity or one, in between two specific quantities. If our average total cost stays the same, we would call this constant returns to scale. And then if I want to produce past this quantity, if my average total costs start to increase, we would call this our diseconomies of scale portion of that long run average total cost curve. Okay. So economies of scale is when we produce more, we're lowering our average total costs in the long run. Diseconomies of scale, if we produce more, we're increasing our average total cost in the long run. And then constant returns is if they don't change. Like I said, in practice, this is going to be a very small portion of the curve, but it will, will exist. Okay. Let me think what I want to do here, because I might save some of this and start out with it tomorrow. I'll go through this quick here the next couple minutes. So I'm not going to necessarily make you, this is a little bit of a foreshadowing of what we'll talk about after the second exam. So after the second exam, each module will be each one of these different types of markets. So perfect competition, monopolistic competition, oligopolies, and monopolies. So it's really this range where if we have a perfectly competitive market, that's like the most, sorry, I'll say it this way. That would be the market where firms have the least amount of power in the market. And then moving towards a monopoly, hopefully this is intuitive. If you know the game, what is a monopoly? It's one firm. So moving towards a monopoly market, that's where firms have more power. So we'll talk more specifically about each of these types of markets, but we will discuss in this module ways we can identify if markets are more or less competitive. Okay. So two measures that we have of this is going to be the four-firm concentration ratio. So this market concentration is really telling us how competitive is this market. If it's very concentrated, right, all the sales are with one firm. Someone's whistling away out there. I don't know if you guys can hear that. If all the sales are with one firm, well, our four-firm concentration ratio, if it's the percent of the market that the top four firms earn, if I only have one firm, that would be 100. Now, as I have like thousands of firms and each of them only have like 0.1%, I now start to get a four-firm concentration ratio, excuse me, that's a lot closer to zero. So these perfectly competitive markets, I'm going to get a concentration ratio that's really, really low. Now, if I had one firm and they owned everything, I said, well, the four-firm concentration ratio, I only have one firm, has to be 100%. However, even if I had three firms, what would my four-firm concentration ratio be? Well, let's say they were splitting it evenly. 33.33%, three firms, add them up, I'd still have a concentration ratio of 100%. So this four-firm concentration ratio is nice for identifying or comparing how competitive markets are, as long as they're competitive enough to have more than four firms. If they have four or fewer firms, all of those ratios are going to look exactly the same. So you can kind of imagine like a four-firm concentration ratio. Let's say I had one firm that was selling everything. Well, that would be a four-firm concentration ratio of 100. What if I had two firms, each 50%? So add up the top four firms. There's only two. Four-firm concentration. What if I have four firms, splitting it evenly? Well, those would still add up to 100. Notice I can't make a distinction if the number of firms is less than or equal to 4. Okay? So it's not the greatest measure. In fact, a better measure in order to identify market concentration ratios, a better measure than the four-firm concentration ratio to measure concentration, and I'll kind of come back to this in a second. Oops, skip ahead, is going to be this HHI. So I'm I know that I'm going to have to end my second section early. So to kind of keep you guys on the same path, we are going to save this discussion, this HHI, and it really shouldn't take us more than probably 5 to 10, maybe. I don't think it'll take us that long, minutes. I'll probably combine the discussion with the practice problems from the practice exam so we can kind of kill two birds with one stone. But we will start tomorrow with finishing up this idea of how do we measure market concentration ratios, not just using the 4-firm, but using this HHI or this Herfindahl-Hirschman index. I'll show you some examples of different markets and kind of make the point of what their HHIs would be. And I'll combine that with the practice problems that we have for those in that. I can scroll down here. Midterm 2 practice exam. Okay. So I'm going to end class a little bit early here today. We'll finish up everything from Module 9, that HHI and the 4-firm concentration ratio with some additional problems tomorrow, the first 10 minutes of class. And then we'll start picking more problems from this practice exam to go through. I'll probably have a little bit more specifics to mention about the exam, but I mentioned them a little bit today. So unless there's any other questions from me, we'll kind of end the recording here.